For this kind of question, I think the quickest way to go would be the work kinetic energy principle. And that relies on being able to calculate the net work, which is not too much trouble, I don't think, in this case, because there's only two forces acting on Iron Man. And I think we can calculate the work for both of them. So that takes care of the left side of the equation I wrote. And on the right side, the change in kinetic energy. Kinetic energy relies on the mass, which we know is 80 kilograms. And it relies on the beginning and ending speed to get to the delta K. We have the beginning speed, and the question's asking us to get the ending speed. So it seems like this equation, it just fits this situation. So in terms of the net work, I'll just do that off to the side. That's going to be work 1 plus work 2. There's only two forces doing work on Tony Stark. One is described in this graph here, and to get the work from a force versus displacement graph, we calculate the area between the function and the displacement axis. So work 1 will be the area of graph. Meanwhile, work 2, let's see what they say about the second force. That's going to be his thrusters. He realizes he is going way too fast and uses his thrusters to provide a constant a constant 5,500 Newton backwards force until he reaches the end of the tunnel. And actually, one more important thing is he doesn't start using the thrusters until he's halfway through. Okay, halfway through the tunnel. So in that paragraph, that sentence, I'm going to say that the work done will be the force of the thrusters times the displacement of the thrusters, of when he was using the thrusters, times cosine of 180 degrees, because the thrusters, that force was backwards, whereas his displacement was forwards. They're pointing in opposite directions, so that's 180 degrees. Just going to label. It's going to be clear. I'll underline with the yellow. This work is done by the thrusters, whereas the area of the graph, that's the work done by the tunnel, the mystical tunnel. All right, so let's continue on there. The area of this graph, so I see a triangle there, so that's half base times height. So that's, so base times height is 5,000 times 100, so that's 500,000. Divide that by 2, 250,000. So now I'm going to focus on the thrusters. So the thrusters, the force is constant at 5,500 newtons. And he does it for half the time, half the displacement of the tunnel, so 50 meters. And cosine of 180 degrees is -1. So it's gonna work to try to slow him down, because he said he was going too fast there. Okay, so let's calculate what this equals, and that'll be the net work. So I'm getting a -25,000 value. A -25,000 value. So the net work done on him was negative. So this actually means he's going to slow down. He's going to end up coming out of this tunnel slower than 30 meters per second. So I'm going to take that value, I'm going to transfer it to my net work equation. Well, first I'm going to do some substitutions and simplifications. So delta K is the change of kinetic energy. So it's the final kinetic energy minus the initial kinetic energy. And what I'm solving for is the final speed. So that means we're going to want K2 isolated. So I'll add K1 to both sides. And then I'll change the k's to half mv squared. I'm gonna break the tradition a little bit. I think I will plug in some numbers here. Might be a little more meaningful. So half times 80 times the starting speed of 30 squared. Net work is negative 25,000. So what I'm doing here is I'm kind of comparing the starting kinetic energy with how much of it's going to be removed from this work. So let me calculate half times 80 times 30 squared. It's 36,000. So Iron Man had 36,000 joules to start with of kinetic energy. The tunnel wants to make this increase, but his thrusters ended up making it decrease overall by 25,000 joules. So he's going to have less joules of kinetic energy. That is what's going on here. And with the fewer joules, we can calculate the new speed. So this ends up 36,000 minus 25,000 is 11,000. And I'll plug in the rest of the numbers now and solve for V2. So it looks like it'll be the square root of 11,000 over 40. Half times 80 is 40. So I'm getting 17 rounded to 2 sig figs here. All right.